This is a small video on luminescence, structural probes, up and down conversion materials.
History of luminescence. It's originated in the middle of 19th century by scientist G.C. Stokes. Now, what is luminescence? It's a process that corresponds to emission of electromagnetic radiation beyond thermal equilibrium. It's a form of cold body radiation. Now, causes of luminescence. It can be caused by chemical reaction, electrical energy, subatomic motions, or stress on a crystal. Now, types of luminescence. It includes chemoluminescence, bioluminescence, fluorescence, and phosphorescence.
Now are the phosphors. Substances emitting luminescence are called phosphors. A phosphor consists of a host solid in which a small amount of impurity is added. The impurity in the host lattice that can be excited to show phosphorescence is called activator. When the activator is such that it cannot absorb the excitation, another impurity in the form of sensitizer is added. The sensitizer absorbs the excitation energy and transfers some of it to the activator, which then can emit. Now this is the diagram showing characteristic luminescence in inorganic material. The Jablonski diagram explains fluorescence and phosphorescence. Fluorescence and phosphorescence are the types of photoluminescence. In Jablonski diagram, there occurs two types of processes: non-radiative relaxation processes, which includes vibrational relaxation, internal conversion, intersystem crossing, and non-radiative de-excitation. And the radiative processes includes fluorescence and phosphorescence.
Now, what are lanthanide probes? They are also known as structural probes. They are non-invasive, that is not harmful, analytical tool used for biological and chemical applications. A fluorescent of lanthanide salt is weak, so we use chelated complexes of lanthanides. Chelated complexes of lanthanides have unusual spectral characteristic property like high quantum yield, millisecond lifetime, sharply spiked emission spectra, broad range of emission energies extending from the blue to the red part of the spectrum. Now, why we use lanthanide based luminescent probes? First of all, lanthanides are metal ions which have their 4f energy levels filled, and the valence electrons are shielded from external interactions. This consequence of the shielding of 4f orbital is that the selection rules forbidding ff transitions are only weakly relaxed, and these transitions are faint. They appear as sharp and weak lines. This apparent disadvantage turns into an advantage since these lines are easily recognizable.
Now are the up and down conversion materials. In down conversion, an incident high energy photon is converted into two or more lower energy photons, which can lead to quantum efficiency of more than 100%. Up conversion, two or more low energy photons are converted into one high energy photon. Principle of up and down conversion material. It consists of a semiconductor with valence and conduction band and with an intermediate level lying inside the forbidden gap. Now, three types of transitions can occur in such materials: between electronic states in the valence band and the conduction band, between the conduction band and the intermediate level, and between the valence band and the intermediate level. In up conversion, the process involves two steps, that is, excitation of electrons from the valence band via intermediate level into the conduction band by absorption of two low energy photons, followed by radiative transition of electrons from the conduction band into the valence band, whereas down conversion involves the reverse process of up conversion. Now are the applications. Application of this is involved in solar cells and in photovoltaic devices.